In this video, let us see some basic properties that we use in fluid mechanics. The first property, the basic first property is density. Density. We also call it as mass density. Density or mass density, both are similar. So what is density? Density is represented by rho, which is equal to mass divided by volume. If there is a container and it is, let us say, 1 meter cube, and the liquid is filled in this. So if we want to calculate the density, then we need to find this mass of the liquid divided by the volume. So what is the unit of mass? It is kg. Then what is the unit of volume? It is meter cube. Kg per meter cube is the unit of density. So sometimes this fluid is measured in liters. So 1 meter cube is equal to 1000 liters. So 1 liter is equal to 10 power minus 3 meter cube. So we need to be aware of this unit conversion. And next, specific volume. So the term specific indicates that per unit mass. Per unit mass. So here it is specific volume. Volume per unit mass. The specific terms are represented with small letters. This is V. V is equal to volume by mass. Volume by mass. So here it is mass by volume, here it is volume by mass. So it can be written as 1 by density. Specific volume is equal to 1 by density. And next is specific weight. So specific weight is nothing but, specific weight is represented with small w. W is equal to weight per unit volume. So this units are Newton per meter cube. Here the units are meter cube per kg. Specific weight is Newton per meter cube. And specific weight can also be written as density into gravity, acceleration due to gravity. This is because weight is mg and volume is v. So mass by volume gives us density into acceleration due to gravity. And next is specific gravity. Specific gravity, or it can also be called as relative density. Relative density. So this is given by small s, and it is density of substance divided by density of standard substance or fluid. So if we need to find the density of mercury, so it is density of mercury divided by density of water. So here standard fluid is water. In case of liquid, fluid may be liquid or gas, and air is the standard fluid for gas. And also the density of water is 1000 kg per meter cube, and density of air is considered as 1 kg per meter cube under standard atmospheric conditions. And next property is pressure. This pressure will be detailedly discussed in the next chapter, but let us see in brief what is pressure. Pressure is the force acting per unit area. Force per unit area. So if I keep a block on the surface, this is weighing 100 kg, and this area is the resisting area is the surface. The resisting this surface area is, let us say, 10 meters square. So what will be the pressure? Pressure is equal to force 100 into gravity acceleration due to gravity 9.81 divided by 10 is the pressure. So if same 100 kg is placed on a small bar, and this bar is placed on a surface, and now this is let us say 2 meters square. Area is 2 meters square. This bar area is 2 meters square on this surface. So now this is the pressure in this case. Here the pressure will be, this is same 100 kg, 100 into 9.81 divided by 2. This will be the pressure. So here resisting area is more comparatively with this one. So the pressure is less. Here resisting area is less compared to this 10. So the pressure is more. And the units of pressure is very important. So pressure is equal to force by area. So this force is newtons and area is meter square. So this Newton per meter square, 1 Newton per meter square is equal to 1 Pascal. And also atmospheric pressure is equal to 101,325 Pascal. So this is atmospheric pressure is 101,325 Pascal, and this atmospheric pressure, which is 101,325 Pascal, is called as 1 atmosphere, and it is represented by ATM. 1 atmosphere is equal to 101,325 Pascal, or it can also be written as 101.325 kilopascal. And there is another important unit called bar. 1 bar is equal to 10 power 5 Pascal. It is also is equal to 100 kilopascal. And there is another unit called 1 torr, which is 1 mm of Hg. So what is this mm of Hg? We will see that in the next chapter. 1 mm of Hg. If this is in terms of length. So in order to convert into Newton per meter square, we need to use this formula, rho g h. Rho is the density of this fluid. Here in this case it is this mercury, and g is acceleration due to gravity, and h is the height to which it is raised. So 1 torr is 1 mm of Hg, which is equal to 133.416 Pascal. So how is this calculated? P is equal to rho. The density is 136. It is 13600. 13,600 kg per meter cube is the density, into acceleration due to gravity 9.81 meter per second square, into height 1 mm into 10 power minus 3 meters. So this gives us, if we calculate it, 133.416 Pascal or Newton per meter square. And also there is 1 meter of water. So what is here 1 meter of water? Rho GH is the pressure in Newton per meter square if it is given in terms of height. So density of water is 1000 kg per meter cube into acceleration due to gravity 9.81 into height to which it is raised is 1 meter. So it is 9810 Newton per meter square or Pascal. We can use any unit. And also there is relation between this. 1 megapascal is equal to 1 Newton per mm square. This is the very important relation we need to remember. If it is given in 1 Newton per mm square or 1 megapascal, it is both are equal.